Welcome. This special seminar is devoted to bioinformatics, and our guests will be speaking about an application that they have developed through Bioknoppix. And it's a real special occasion because it's the first time that the RCMI program is webcasting one of its seminars, one of the seminar series. So I think I'm very excited about this event. Our guests are Carlos Rodriguez and Humberto Ortiz-Suazaga, both from the High Performance Computing Facility, which, by the way, is one of our partners because they've been very helpful to us in terms of developing informatics in the campus. And they also run the Internet 2 project in Puerto Rico, so we're very grateful to them, and we're very happy to have Humberto and Carlos here to talk about these applications. Well, Humberto and Carlos, welcome, and let's start.
Good morning. My name is Carlos. I'm going to talk about a little bit of Bioknoppix and what we do at the HPCF. So let's begin. First, who are we? The short answer for that is a bunch of computer geeks. The executive one, is the High Performance Computing Facility, is presently developing a technology, service, and computing infrastructure for the research and education community of the university. So basically, we provide services, computing resources services to the university community. Some of the services are Internet 2 connectivity, software development, scientific computing, databases, web services for research like web hosting, emails. We provide facilities for video conferencing, and we give training and support to whomever wants to know more about open source software. So right now we have at the HPCF a Bioinformatics Resource Center. For this center, we currently have 2 big machines dedicated to bioinformatics. The first one is Cafeína. This is an SGI Origin 300. This is a shared memory computer. So if you don't know what shared memory means, is basically you can see it as a really big machine. You know, you can see it as a PC that has 32 processors and 24 gigs of memory. The other machine we have is not fully deployed right now, but we are getting there. Is Espresso. This is a Linux cluster. If you don't know what a cluster is basically a bunch of PCs that we put together to make a big machine, more powerful machine. So these 2 computers are dedicated exclusively to bioinformatics computation. Some of the areas supported by the BIRC is genomic and proteomic databases, sequence analysis software, phylogeny software, protein structure prediction, bioinformatics programming, microarray visualization and analysis, biostatistics, and support services and training. So what is Bioknoppix? Bioknoppix is a customized distribution of a Linux light CD named Knoppix. So the special thing of Bioknoppix is that it is loaded with bioinformatics applications that I will show you a little later. So a Linux light CD is a CD that you just put the CD on your PC, turn on the PC, and it will boot from the CD. Then you will get a full operating system with everything loaded. You have applications, you have internet connection, you have everything you need on an operating system without touching the hard disk. Actually, you don't need the hard disk to run Bioknoppix or Knoppix whatsoever. So this is a question that many people ask. Linux, why not Windows? So historically, bioinformatics applications were developing for high-performance computing environments, and these environments are generally Unix-based. Another reason is that Linux is open source. So there's a saying that it is free as in speech, that you have freedom to do with it whatever you want. You can modify it, you can repackage it, you can do whatever you want with it and redistribute it, sell it, whatever you want. And could be free as in beer. As I say could be because sometimes it is not free. It has a cost. For example, there are companies like Red Hat or Mandrake that they sell the operating system, and you can buy it for like $50 or something like that. But there are other distributions like Debian, which is completely free. They don't charge anything. Actually, there's no company behind Debian. It's a community initiative, and it is community supported. So another advantage of Linux is that you don't have add-on costs. With Linux, you get basically all that you need to provide services like web server, mail servers, databases, programming languages. In Linux, you get everything out of the package. You don't need to buy Visual Basic license over it. You have a full development environment with it, and many more. Maybe Humberto has more advantage of Linux over Windows. So, a short story about Bioknoppix. We use Knoppix at the HPCF for diagnostic, repairing PCs and giving demos to people. So Humberto was giving a bioinformatics class last year. Actually, it was this year, right? No, last year. Last year. And so we thought it would be nice to have a Knoppix version for bioinformatics, so that people the students could have a standard CD where they have their environment, and even when they have different computers at home or whatever, they could practice what they were teach at the class. So we did that for that class, and then we distributed to everyone. So these are some of the applications inside Bioknoppix, bioinformatics related, of course. The first one is Emboss. This is a sequence analysis suite. This is a suite. It has more than 100 applications for different tasks with sequences. You can edit sequences. You can do whatever you want with regarding sequences with this application. JEmboss is a Java interface for Emboss. Artemis is a genome viewer and annotation tool. You can annotate genome or sequences with that. It's a graphical application. ClustalX is a graphical interface to ClustalW, which is a multiple sequence and alignment program. CN3D is a 3D viewer for structures, protein structures, or molecule. ImageJ is an application for image processing. BioPython are Python tools for bioinformatics. BioPerl, the same for Perl. Bioconductor is like a suite of applications for microarray analysis developed on R, which is an statistic programming language, and RASMOL, which is another molecular viewer. So with Bioknoppix, as I told you, you have a full bioinformatics development environment inside the CD. You can program in Python or C or C++. You have compilers there. You can do whatever you do with a full install OS in Bioknoppix. So you could run scripts that you have created in BioPython, for example, or BioPerl, and everything is there. So the mission of Bioknoppix is to have a working environment attractive to the life science community. So what I mean with this is that everything that I included in the distribution is workable. You can do actual work with the tools that we have there. So when I was doing this, I was going to install BLAST, for example, but I didn't do it because for BLAST you need the databases, and I couldn't squeeze enough databases inside the CD so you can do real work with it. So I decided not to include it because it was going to be there just for showing off and not doing some real work. So I didn't include it. That's what I mean with a working environment. So another mission is to break the ice such that people lost the fear of Linux. Many people don't use Linux because they are, oh, I have to install it in my computer. Oh, I have to do this. I have to do that. So with this, you don't need to do anything. Just put the CD, turn on the computer, and that's it. And to give a sample of just a sample, there's a full universe of bioinformatics applications developed in Linux that are free, are open source. You can modify them. You can do whatever you want to do with them. So now I'm going to do a little Bioknoppix demo, but you can get the CD from bioknoppix.hpcf.upr.edu. You can buy it. I think it's $5 for a CD. These companies, you ask for the CD and they send you a pre-born CD to you. So you just have to get the CD and make sure your computer boots from the CD. That can be set on the BIOS. Many computers, that is the default, but many don't boot from the CD. You have to set that in the BIOS. So you insert the CD, turn on the PC, and that's it. Now I'm going to change the computer. I'm going to use a PC for the demo.
That actually the hardest part of Bioknoppix is getting your PC to boot from it in the first place. But if you have trouble and you'd like to try it out, you can drop a note on the Bioknoppix forums or send us an email at the HPCF and we'll help you sort it out. It's usually you press some key combination while the machine's booting up and then you can read the CD or switch to a menu.
We could also be available for help here.
Okay.
We can talk and
See.
be available too.
I just I have my home for Knoppix in this USB pen. So I just going to put that there. Write Knoppix home equals scan. It will look through all the devices that are connected to it to look for the Knoppix home to the Knoppix home my folder. I have there sequences preloaded because I don't have a network in this machine, but you can do whatever I'm going to do here. Just connect it to the network and it will work. So you see, this is all booting from the CD. This machine is not installed with Bioknoppix, so it takes a little while to boot, but so I could, you know, have the computer ready, but I wanted you to see how you can just insert the CD and boot and turn on the machine and that's it. It takes a while because it's uncompressing everything that it needs from the CD. What Knoppix do is that it uncompress as needed. You know, if it don't need something, it will not uncompress it, right? So that way you can fit 2 gigs of space, of this space, in a CD. So here you have information about Knoppix. You have, you know, documentation about it. So I just want to show you some of the programs that are contained here. So first of all, Emboss. I told you that you had plus 100 programs there. This is the list of the programs that you have in Emboss. You can see there are many. Right, you can do a lot of stuff with it. I don't know for what are half of the program there, but you can look through it. If you want, for example, to know about the program that do alignment, you just write was name with the search key, and it will return you a list of programs that has to do with alignment. So you can see the description there, and then you can select whatever program you want. So I have some sequences here. I'm going to do an example with XL rollup, which is a CDNA clone of a rollup sim. A rollup sim is a protein related to light reception. This example is specifically from a frog, Xenopus. So first of all, I'm going to show you the sequences. this is one of the sequence, and so I'm going to begin doing an alignment, a dot plot alignment of the two sequences. One is the cDNA clone, and the other one is the original sequence. So it's the first sequence. That's the original. So as you can see there, this is the alignment between this sequence and this sequence. You can see the diagonals, and I'm going to show you later. There are 5 regions that align perfectly with one and the other. So it makes sense because it's a clone. One is the clone of the other. So this one doesn't have all the portion that doesn't code from this sequence. So these only have the coding regions. Okay. Thank you. Come on. So I have the flat file for the sequence. You can see there is the description, and here you have, for example, the mRNA, the regions of the sequence that are RNA, the conserved domain. So you can see it there, but if you're a computer, you can understand that. But if not, you need a more easier way to see that. So you can do something show fit. What this do is show the features of any given sequence. So as you can see there, now you have the sequence, the mRNA here, and the conserved domains. So you can see that these 3 mRNA regions are conserved entirely throughout the, you have a match there with mRNA and the conserved domain, and this one and this other here are not entirely conserved. So I'm going to do an experiment here. I'm going to do a dot-up alignment with the sequence and another rhodopsin, but from mouse. You can see there that you have 1, 2, 3, and 4 alignments. You don't see the other one because you remember from the previous image that you didn't have the conserved domain. So you can get, this is the kind of stuff that you can do with emboss. You can do a lot of different things. There are things for many processes involving sequences, and everything is working there. Actually, if you have a network connection in the machine, there are pre-configured databases that are accessible through the web, so you have something to work there.
You can get access to GenBank and EMBL.
EMBL, yeah. So that's with Emboss. You can, TFM is for getting the manuals for the application. So for example, I use .up. I'm just going to write .up, and you get the manual there. You get the function, the description, you get the usage, how you can write it on the shell.
That's a working example too.
Yeah.
You can actually run that on the CD
And it will work. So you have the different arguments, all the stuff associated with it. So most of you could see this and get scared because of the complexity of having to write commands and stuff. But there are many interfaces to Emboss. For example, I'm going to show you one. See here, I have a takes a while, it's Java.
But full documentation for every one of the 130 some Emboss programs is available on the CD as well. So you can look for programs using WASP name and then read up the manual using TFM.
So
Much better, kind of. This looks much better.
yeah, it looks less scary for some people. It looks more scary for me. but it's very intuitive. It's a simple interface. You just click the tabs here, and you just get your for example, this one, infosec, display some information from the sequence. You put the sequence there, you check whatever information you want to get from the sequence, and then you click go, and then you can open the result of the run that you did. So you have here a alphabetic list of the application that are inside Emboss, and this is by category. So you have that also there. So another of the applications that we have here is ImageJ, for example. Have someone of you have used ImageJ before?
Or NIH image.
Or NIH image, which is the same. Okay. So I just going to do a quick example here. If I go to at home. So we have this image. These are embryos So let's say that you want to count the embryos that you see here and have a size distribution of them. So you can just have to put the image in black and white. Subtract the background. I'm telling you here that don't take any of these dots that are below 20 pixels. So I want to do a size distribution, and I want to display the results, and I want to show the outline of the images. So this will do some calculations. So now here you have a numbered, set of the embryos that you have there. You have the size distribution from smaller to larger, and you have the somewhere around here. Okay. There you have the individual result for each one. For example, the number 1, you have an area of 815 pixels. So you can have an idea of what you have in your image. So this is a quick example. So another of the.
Is there any way of converting that to metric units?
Yeah. You just there's a configuration file. I think you can just change it through the application, and yeah, you can change the units.
Some images have image calibration information embedded in them, and then you can usually just open the image up and it'll know it's millimeters instead of pixels.
So I'm going to. Many people have used Rasmol, right?
Sure.
So Rasmol is included here. You just can. Let me show you. File open. I have this molecule here. Sorry. Anyway, I can change how it is presented. You can select some portions of the molecule. You can color it whatever way you want. You can. You see, you can do the display whatever way you want. You see that thing there? You are that blood. You are inside the molecule. That's like the molecule. It's outside of the range of the screen. So. You can color it by group. So just for you to see. So also I have Artemis, which is a genome viewer and annotation tool. Just going to open one file that I have here. One of the sequences. This one that has the features. You can see there the features, the conserved domain, the mRNA portions of the sequence. You can create new annotations. You can go here and create a new feature. You can mark open reading frames. This is for annotation. You can do whatever you want, and then you can export it in a GenBank flat file or whichever format you want. So you can see that. And most important, you can play with. So there, it's not only for bioinformatics, you can have it for your kids also. So I'm going to go back to the presentation just to wrap up. Now it's going to shut down. It will shut down, it will eject the CD, ask you to press enter, and then your machine is turned off and you have your CD out. So.
And your computer's back to normal.
Yeah, and you can get Windows up again. So. So there are similar projects to Bioknoppix. Like a month after I did Bioknoppix, there was this version, Big Jan CD. It's based on Knoppix also. It has almost the same application as I did.
A little more chemistry.
And it has a little bit more of chemistry applications, so there's another option you can play with. This is another distribution, but this is not based in Knoppix. It's based on Slacks, which is another live CD. So you can play with that. Linux. Another. This is new, right?
Is that the one that is a system image or image?
Yeah. This Bioknoppix is it's a distribution, but it is not a live CD. You basically what you get is an image that you have to put in a new computer, And then you have all the applications pre-configured and you know. And BioBrew, that this is what we currently use in our cluster. So it's a operating system for clusters, but it's loaded with bioinformatics applications. So there, and for Knoppix, you can find Knoppix for everything. You know, you have Knoppix for security, for a lot of stuff. So here I have different links that I like to visit often. This is bioinformatics.org. There you will find a lot of bioinformatics projects, open source projects. You have Nopper.net, which is the people that created Knoppix. Knoppix.net, this is not the official page, but it has a lot of information regarding Knoppix. And it's in English. This is in German. So you would like to read this one. OpenSource.org, they have a lot of, they have a lot of news there of new projects and interesting projects in open source. Linux.org, you can find information about Linux there. And I like this link really much. This is a link directory. There in Canada, I went to take a course to Canada with these people. They have a link page that they have organized by category. They have different links, like for example, operating systems, bioinformatics applications, DNA applications, protein applications. They have links to web pages that do work with bioinformatics. This is a really good directory of links. So our purpose for giving this talk is to promote the use of open source tools. It's cheap, you don't pay for it, and it's good, So, and to let you know that sometimes people need some sort of software and they start looking for buying. And just to let people know that sometimes you are looking for a software, to buy a software, and most of the time it's available free. There's an open source alternative to many softwares. So, and to introduce the resources and services that we provide, and where to get Bioknoppix, you can visit this webpage, bioknoppix.hpcf.upr.edu, and there you will see a web page with resources and everything. If you have any question.
If you have any questions, please go to the microphone because we need to transmit that to the web.
There's no questions?
No, I have to.
Okay.
Sorry. Thanks a lot. Just a couple of questions. One is, what about people who have Macs in their labs, and like you do, and they want to run these kinds of? That's one thing, and the other thing is, you call the programs directly from the command line.
Yeah.
Do you have any interface like GNOME or something? You can actually
all the programs that I did write on the command line are available through the JMBoss interface.
Okay.
It's just that I like more to write on the
Yeah,
shell.
but is this just the MBoss applications? Because there are other tools. Can
Yeah,
you
but
also call those from the MBoss application?
No, the other tools are graphical tools that you get them from the menu.
Yeah, but you can actually do you have, for example, how do you call it, GNOME, that you can actually call the programs from the interface without having to write the
Yeah.
the command lines?
Yeah,
That's
you,
okay.
you just go through the
Go to the
menu.
program and that's it.
Yeah.
Okay.
And for the Mac,
Yeah.
you don't need Linux to run these applications in Macintosh, because Mac OS X is Unix based. So there's one, and the other thing is that I didn't create Knoppix, I just modify it. So there are people working really hard to make these bootable distributions. And I think my guess is that they don't like to develop for Mac because there is not a large interest in doing Unix-like operating system on a Mac, which is already a Unix operating system. So it's just changing the flavor.
That means that anyone having a Mac machine can also run these programs with
Yeah,
no
most of
problem.
them.
Most
Yeah,
of them.
Most of them.
Okay.
Yeah. Yeah.
You already have most of them.
Yeah. I have some of them.
Morning. I guess that if you're using Knoppix, you can't use any PC programs at the same time. Is that correct?
You could, but you would not like to do that because there's, for example, if you want to open like PowerPoint,
Mhm.
you could do it, but you need Wine, which is a program to interface.
It would be like an emulator or something?
Yeah, it
like
would
that?
be like an emulator, and it would get very, very, very slow. So it's not feasible to work with it.
Is there a way to do it the other way around, to open an emulator, a Unix emulator under
Again,
Windows?
Again, it will be really
Very
slow.
Okay.
Yeah.
Thank you.
Yeah, you could do it, but it will take forever. Any other question? So, thank you.
I need your signatures for the.